Hello everyone. Thank you for having me here. It's an honor to be here with 12th International Conference on Innovations in Bio-Inspired Computing and Applications. Mr. Vishal Pawar and I, Sneha Nagar, representing as co-authors from Electronics and Communication Engineering Department, and Mr. Virendra Dani, representing as a corresponding author from Department of Computer Science and Engineering. We all are from Shivajirao Kadam Institute of Technology and Management, Indore. Here, I am going to present a paper titled An Analysis of Multipath TCP for Improving Network Performance. The entire presentation contains different slides which describe our research work. The next slide is abstract, which will give short overview of this paperwork. Multipath Transmission Control Protocol has the potential to greatly improve application performance by employing several routes. Multipath TCP was intended to be a backwards compatible alternative to TCP. Accordingly, it exposes the normal socket API to applications that can't manage how the different routes are used. This is a crucial attribute for various functions that are uninformed of the multipath behavior of the network. This is a restriction on applications that may advantage from particular information in order to employ numerous paths in a way that best suits their requirements. If these many paths could be used simultaneously, network resource use would be more efficient. This should improve the user experience by improving network stability and increasing throughput. We proposed MPTCP, which permits a particular data flow to be divided into several paths. The technique starts with quantum physics for encoding and population generation, then moves on to a generic algorithm for searching the generated population. This has the key advantages in terms of reliability and connections and may even continue if one of the path fails. The proposed work has been implemented in NS2 with MPTCP protocol modifications. The next slide is about introduction. The Internet's success is due to its capacity to provide reliable end-to-end data transmission services for a wide range of applications. Data packets from various traffic flows share network resources on a best effort basis. As a result, every network carrier makes every effort to get packets to their intended destinations. Demands on internet resources are rising as the internet advances. However, these resources are frequently underutilized due to protocol limitations on both end systems and inside the network. Hence, modified versions of TCP is multipath TCP that enables multipath transport and accomplishes, which aims transparently to the application by pooling several routes inside a transport connection. Primary need for implementing MPTCP is to improve the throughput and resilience. Now let's discuss multiple subflow in the next slide. Multiple subflow can be set up for a single MPTCP session using multipath TCP. An MPTCP session begins with a primary subflow. Additional signaling between the end hosts is required by MPTCP. It accomplishes this by utilizing TCP options to accomplish two given objectives. First, to create an MPTCP connection for the first time. Second, subflows can be added to multipath TCP connection. And third, use multipath TCP connection to send data. The next slide is about the literature survey. Honglin Lee et al. Presented a delay-based congestion management method. Shiva Raj Pokhral et al. Created a complete technique capable of measuring performance of long-lived MPTCP flows with combined Wi-Fi and cellular network access while taking into consideration the differences between the two types of networks. Lucas Koffingner et al. Presented a large-scale empirical investigation of MPTCP's efficacy and practicability in data center and cloud applications under various network circumstances. Tuang Zhang et al. Studied the problem of data delivery in order to improve the quality of service and quality of experience. Chuan R et al. Compared the performance of multipath TCP against that of TCP using a new metric that they created and then observing how these performance change when other parameters are changed. Now, let's discuss the objectives in the next slide. The specific objectives of this revision are: first, examine the elements that influence MPTCP's execution. Second, implement the original MPTCP to evaluate its performance. Third, modify the elements that impact the original MPTCP's performance. And last, evaluate the performance of the modified MPTCP. Now let's discuss the methodology of the proposed system. We will schedule the data in a manner such that packet arrives in order to the receiver. This will enhance the performance of the existing MPTCP. First, we use two nodes to construct the multipath network topology with two subflow and three subflow. Next, in the above diagram, we use two nodes and two subflow to construct the multipath network topology. Likewise, we have to construct the same network for two nodes and three subflows. As one can see in the next slide, the next steps are selection of source destination and simulation with the two subflows. The total throughput congestion window, average waiting time, total number of retransmissions will have to analyze for each scenario. Finally, generate a graph for the performance of MPTCP and the proposed algorithm with MPTCP for the performance metrics. As may be seen in the next slide, due to number of retransmissions, average waiting time per segment, congestion window of each subflow, global throughput by combining the individual subflows throughput, we can demonstrate that our proposed modified TCP would obtain efficient results when compared to the existing TCPs. The next slide is about the simulation. The suggested study is performed using the NS2 Network Simulator version 2. Furthermore, the following configuration is available for performance evaluation and simulation. This section depicts a simulation of MPTCP. Now let's discuss the results. Figure 3 depicts the comparison of method for window size and figure 4 depicts the comparison of method for sum of retransmission. The next slide shows the figure 5 in which the comparison of method time delay of link is shown, and in figure 6 comparison of method in network throughput is shown. In the next slide, that is in figure 7, comparison of method for window size and comparison of method for sum of retransmission are shown. In the next slide, as one can see in figure 9, comparison of method for time delay of link, and in figure 10, comparison of method for network throughput are shown. The next slide is about the conclusion. The most important update to TCP in the last 20 years is multipath TCP, which allows current TCP applications to gain improved performance with reliability in current network environment. This work is present multipath TCP method which can improve performance of TCP in disparate wired or wireless scenarios. By utilizing multiple paths from sources to destinations and duplicating TCP data packets on these multiple paths, the MPTCP can significantly decrease packet loss rate from end to end. This study uses this implementation to explore performance of MPTCP in a variety of real-time circumstances, including data centers, mobile communications, and multi-homed networks. The next slide is about the references which were included to prepare the entire proposed work. Thank you.